section 2, we've got some technical looking symbols that we'll encounter. There are formulas that go with many of these. If you're into memorizing formulas and stuff, I'll let you look at the book. If you could read your book in the first place, you wouldn't need me telling you about all of this, but you can do a lot of this by visualizing rather than remembering formulas. Here is a situation where we've got two sets labeled A and B. What we're looking at is A intersect. That's this upside down U between the A and the B. Now, the A intersect B needs to be related to the A and B. This is kind of easy to remember. If you look at the symbol for intersection, it kind of looks like an A without the line across the middle. So and A and A and B, or A intersect B. That's where the two overlap. Likewise, the other symbol that looks like a U stands for the word union. That's easy to remember. U, union. However, these are described as A or B. What you see colored here represents things that are in set A or in set B. Things in this region are in set A or set B. They're in set A. Things in the football-shaped region in the middle are actually in both A and B, which is what we saw in the first one, but still they fit the description A or B. And so this is A or B. A union B means put everything together. Now here we got some specific numbers to go by. If we're asked to find the probability of A intersect B, or more appropriately A and B, our bottom number of our probability needs to be all of the numbers together. So if we add all of those up, that would be the bottom number of the probability. The top number of the probability is the one that corresponds to this region, A intersect B, the region that is in both A and B. That's the one that I've got shaded right here in blue. And so there's a 39 in that region. There's a 100 altogether. 39 over 100 is the probability of A and B. Look at this. A union B, also called A or B. What's the probability of A or B? Well, these are the same numbers as the previous one, so the total is 100. But this region, A union B, represents all of this shading. And so taking those numbers, adding them all up, we get this 74% probability. Now here, the A with the little mark up there, which is called A complement, or the mark is read prime, A prime, means everything that is not in A. And so we want to take everything that is not in A, that's the part I've got shaded in blue, and everything that is in B, and put all of them together. Okay, so this shaded region, taking the numbers that are in those shaded regions and putting them together, gives 86. Let's try another one. This one, we've got the set A, shaded in blue. B with a little mark means everything not in B, everything outside of set B. We want to know where do those two overlap. And so 14 out of 100 would be the probability. Now, let me show you a different one. We're rolling some dice. We've done this one before. Here's all the ways that the dice can land. And we want to know the probability the sum is 4 or 9. Now, since we have everything laid out before us, we can just go down the line. Is the first one the sum 4 or 9? Well, 1 plus 1 is 2. That's not a 4 or a 9. So we can take that one out. And we just go down the line with each one and say, is this a 4 or a 9? The second one is 1 and 2. Does that add up to a 4 or a 9? No. 1 and 3? Yes. Take out the ones that don't add up to 4 or 9. All of these add up to 4 or 9. Count the box. There's 7 out of the 36. Look at this. What is the probability the sum is not a 5 or a 7? Again, with a problem like this, we can just go to each block and ask ourselves, is this first pair of dice, 1 and 1, going to add up to give a 5 or a 7? We want to know, is the sum not 5 or 7? And the answer for this first one is, yeah, it's not 5 or 7. So we will count that one. Now if we take out all of the 5s and take out all of the 7s, then everything else must not be 5 or 7. So they all fit the description of not being a 5 or a 7. Now see, we've done that without any fancy formulas. I haven't even shown you the formula, and you can still come up with the probability. Okay, count the box. So let's do another one of these. What's the probability the sum is 5 or one die is a 3? Again, we can go to each pair and look at it. This first one has a purple one and a green one. Is the sum 5? No. So we don't even need to go any further. So we can not count that one. And how about the second one? Is the sum 5 or is one of the die a 3? No. Third one, 1, 3. Is the sum 5? No. Or is one die 3? Yes, it is. The green one is a 3, so we would count that one. And so on. We could just go down the line, counting all the ones whose sum is 5. Or one die is a 3. These are all the ones whose sum is 5 or one die is a 3. Count them up, divide by 36, that's our probability. Now here we'll use this in the future in computing some of our probabilities. The probability a candidate will win the election is 51%. What is the probability they will not win? Well, the probabilities have to add up to 100%, and they either will or they won't win the election. If this is 51%, the other probability of not winning has to be 100% minus the 51%. If we know that the probability of drawing a card from a deck is 20%, then the probability of anything else happening has to be 100 minus 20%. If we know the probability of a male applicant getting a job is 40%, then we know the probability of a female has to be 100 minus 40%. The last topic in this section is on the idea of something called the odds. This is used a lot in gaming situations. The odds in favor of an event is the probability for the event divided by the probability against the event. Usually these come out to be integer values that we express in a particular way. The odds against something happening is just reverse of that. And so here's a problem that we've dealt with before. We're going to roll a die and find out about rolling a 2. Well, the die is numbered 1 through 6, so there's 6 sides. Only one side has a 2 on it, so the probability of getting a 2 is 1 out of 6. The probability of getting anything else is 5 out of 6. That means the other 5 sides of the die. And so the odds of, or in favor of rolling a 2, would be a 1 over 6 divided by a 5 over 6, which reduces to 1 over 5. Now, odds are generally expressed like the second one, 1, 2, 5, 1 to 5. This is 1 to 5 odds. Here's the idea of odds in gaming situations. If the odds on something are 1 to 5, that means if you bet $1 on it happening, and it does happen, you should win the $5, like in horse races.